In the 1970s, a group led by Dr. Masataka Hanashima of Fukuoka University in Japan began to look at ways to deal with water pollution and bad odor at landfills with no control level. Their main interest was in regions where budget and local expertise were limited, so places where anaerobic landfill wasn't really an option. The result was the semi-aerobic landfill, also known as the Fukuoka method. It's a method that's since been adopted in over 20 countries around the world and is the subject of this module. The defining features of a semi-aerobic landfill are a network of horizontally arranged perforated pipes laid out across the bottom of the site. Connected to these are a series of vertical gas wells. The horizontal pipes capture the leachate, draining it safely to a collection pond, whilst at the same time drawing air into the landfill. This inflow of air stimulates aerobic biological activity. The effect of this is that the quality of the leachate is improved. The generation of the methane is suppressed. The waste decomposes faster, which means the site becomes stable sooner. This in turn means that the site can be rehabilitated quicker and with less cost. The design mostly generates carbon dioxide instead of methane. This is vented via the vertical gas wells, with the pipes also drawing in air. Whilst carbon dioxide is still a greenhouse gas and a major factor that's causing climate change, it is nonetheless around 20 times less harmful than methane. Leachate, as you'll remember from the previous modules, is a toxic soup that is generated when rain and moisture seeps through the waste, picking up organic and inorganic compounds along the way. Controlling, managing, and treating leachate is a primary function of any controlled landfill. Semi-aerobic landfills start that process within the landfill itself. One of the key indicators used to assess water quality is biochemical oxygen demand, or BOD for short. BOD measures the amount of oxygen required by microorganisms to break down organic matter in water. A lower BOD figure indicates better water quality as it reflects less organic pollution. This chart shows that leachate quality improves much more quickly under semi-aerobic landfill management than under anaerobic landfilling. This is because the semi-aerobic processes accelerates the reduction of BOD levels, leading to cleaner, higher quality water. I still wouldn't recommend drinking it, but what it does mean is that there is far less chance of environmental damage being caused, and is easier and cheaper to apply the treatments needed to make it fully benign. However, it's important to note that leachate quality improvement is not automatic. Proper daily site management and leachate control are still essential to ensure effective treatment. Without ongoing maintenance and careful management, the pollution level of the leachate will not improve, regardless of the treatment method. Seen here is the layout of a typical semi-aerobic controlled landfill. The management zone is located near the entrance. There's a workshop, a site office, a vehicle weighbridge, and vehicle washing facility. These help the site operator to administrate operations and maintain site equipment. The completed site zone is the area that was established and filled first. It's now complete and no longer receiving waste. The waste is now covered and stabilizing. The only evidence of this being a landfill are the vertical gas wells sticking out from the surface and the engineered side slopes. These indicate the presence of waste below. This is the ongoing daily waste reception zone. We can see the newly established cells that have the leachate pipes and vertical gas wells in place. There's a well-maintained site road leading to a waste drop-off point. Machinery pushes, layers and compacts the waste into place around the gas pipes before cover soil is applied. And here's the leachate treatment facility zone. This is where the leachate pipes exits the landfill site into a controlled pond. The leachate can be recirculated to the waste or treated here prior to discharge. Sites are often built above ground level to enable gravity drainage of leachate from the site rather than requiring pumps. Therefore, an essential element of semi-aerobic landfill are strong perimeter embankment walls. Embankments are essential for landfill structure. You can see here slopes at the edge of the landfilling area where the collapse of waste has occurred. This was caused by uncontrolled and unplanned landfilling of waste, where waste was pushed outward without compaction. And nor was there any embankment. So, as you can see, proper embankment construction around the peripheries of a landfill, including good compaction and fine slope arrangement, is critical for landfill safety. When building embankments, an overall average slope gradient of no greater than 1 to 2 must be achieved. So, 1 meter vertical by 2 meters horizontal. This will allow more waste to be piled up while forming more stable slopes with good compaction. It will also create greater capacity for the entire landfill site. Also, if cover soil is applied and vegetation is planted on slopes, roots will prevent waste from spilling out due to rain and winds. The scenery around the landfill site will also be improved thanks to the plants. Flowers, vegetables and fruit trees can even create an income opportunity by selling the harvests. Greenery and thriving plants are also a good indicator that methane levels are less than 5%. Additionally, if embankments are constructed first and landfilling is conducted after that construction, local people won't see waste being dumped and the operation of heavy machinery. So far then, this looks much like any other controlled landfill, apart from these raised channels and what looks like chimneys. These are the leachate pipes and gas venting systems and are what make it a semi-aerobic site. The leachate pipes have two functions. One is to collect and drain away the leachate. The other is to allow air to flow into the waste mass. Because of this, the pipes need to have a wide diameter. Pipes made of reinforced concrete with a diameter of 60 centimeters is optimal. But where local concrete isn't so strong, 2 pipes running side by side, each of no less than 30 centimeters will suffice. Perforation holes should be around 25 millimeters in diameter and appear only on the top 2/3 of the pipe and positioned as shown in this diagram. An advantage of semi-aerobic landfills is that the risk and level of toxic leachate reaching and seeping into the ground is far less. So, whilst the geomembrane liner is always good, tightly compacted clay does an equally good and less costly job. The pipe can rest directly on the ground, either the liner or clay. Crushed stones of around 10 centimeters diameter each need to be arranged around the pipes as shown here. The stone area enhances microorganisms' activities and is crucial for methane gas reduction and leachate purification. They also prevent waste clogging of the purification holes. The installation of a sufficient amount of crushed stones on top of and the surrounding leachate collection pipes is very important. The volume and placement of these stones needs to be consistent along the length. Using a simple wooden gauge like this is a good way to ensure consistency. The gas venting system is a simple structure that prevents the buildup of gases within the waste mass, as well as further enhancing the intake of air into the landfill body. They can be made of things you're likely to find lying around the landfill, but we'll use this old 55-gallon oil drum as an example. Remove the top and bottom. Perforate the sides and then fill with cobblestones. For each system, you'll need 3 of these positioned like this to surround a central perforated venting pipe. This can be made of PVC, metal or bamboo. When constructing a brand new site, the vertical venting pipe should connect to the horizontal leachate pipes. This will allow incoming air to permeate deeper into the landfill body. You'll also have the opportunity to construct a stable footing for the venting system as seen here. This can just be a simple bit of brickwork with wooden slats on the top. However, if installing the system at an existing site, this may not be possible and great care is needed. In this case, it's important not to dig too deep for the system installation. There is a possibility that methane or other harmful gases has already generated inside and the hole might be filled with harmful gases. We recommend that digging should be limited to the depth where workers can always reach fresh air. Here, the venting system can be secured by placing it on some cobblestones, which should also be arranged to provide side support. It may be necessary to extend the height of the venting system as the landfill fills up. This can easily be done by placing additional drums on top of the existing ones and extending the central perforated venting pipe. Place some strips of wood, bamboo or similar in 3 places around the top edge of the bottom drum to ensure that the two align. If you can't find any old oil drums, tyres make a good substitute, but you should insert a wedge between each to allow air to permeate through. You're very nearly there with the construction of your semi-aerobic landfill, but there's one more important step to go. Leachate. Scientific tests carried out have shown that semi-aerobic management can treat leachate pollution more quickly than anaerobic management. Here, chemical oxygen demand, or COD for short, is one of the key indicators to illustrate water quality. The lower the COD figure, the better the water quality. But, as I mentioned earlier, we cannot leave it at that. Further treatment is needed for this, and we need a leachate treatment pond. This is a facility connected at the downstream end of the leachate collection pipes. The pond collects the leachate and further reduces its pollution level. The required capacity of the pond must be calculated by considering the size of the catchment area the landfill site serves and how much rain the region gets. There are various ways of treating leachate. One simple way is the installation of an eco-fan, which you can see here. It's made from a dustbin, bicycle rims, and the plastic blades you'll find on general household electric fans. The fans, placed under the surface of the leachate, rotate by winds collected by half-cut dustbins stirring the leachate. This enhances the aeration of leachate. An eco-fan is a good, low-cost, low-maintenance starting point for leachate treatment. But it's only suitable for dealing with wastewater pollution caused by organic matters. It cannot deal with non-organic waste such as heavy metals. Where these are present, it's possible to use a landfill as a filter by passing the leachate back through the site. This keeps the toxic waste elements in the landfill as much as possible. However, leachate recirculation is only possible by pumping back the leachate from a leachate treatment pond at lower ground to the top surface of a landfill structure. So do keep in mind that either electricity or fuels are essential to keep the pumping system running. There's also a risk of mechanical failures of the pump. So mechanical engineers must be regularly available to fix problems if they arise. The most effective and advanced way to treat leachate is through chemical and mechanical processes. But this is very costly and demands very high operational and maintenance skills. Reaching this level of leachate treatment is only possible when previous steps are achieved. There are other methods of leachate purification. The tornado system and biotopes are two examples. We're not looking at these in this course, but by all means do some research yourself. A final point on the treatment of leachate is the need for careful monitoring and control. Monitoring sensors at the liner area can be added at the construction phase along with other similar equipment. But the more advanced things are, the higher the capital and operational costs and higher technical management skills are required. However, all that is required initially is for field staff to gradually increase their competency in the monitoring of gas emissions and leachate. This, along with the gradual introduction of technology, can be expanded over time. Semi-aerobic controlled landfills offers a significant advantage in site stabilization, achieving stability in approximately 30 years after final usage and closure. This is a much shorter period compared to anaerobic landfill management. Once proper monitoring is conducted and site safety is confirmed, the stabilized landfill can be repurposed for various uses. These include green spaces, parks, and even low-story building developments, allowing the land to serve the community in new and valuable ways. The goal of this controlled landfill management approach is to maximize land usage for the long term, even after waste reception has stopped. This ensures sustainable and beneficial use of the site for future generations. Former landfills in Fukuoka City today hold a range of facilities widely used by the residents. These include a special school, a citizens' farm, and an athletic park. Long-term monitoring is conducted for items like gas release, subsidence, corrosion, and other environmental concerns. Let's now take a look at the pros and cons of semi-aerobic controlled landfill. The pros first. It can reduce methane gas generation at landfills. It can treat toxic gases and leachate from landfills at relatively low cost and with simple management skills. The method can be introduced step by step. This means you can gradually upgrade each function of the landfilling as and when needed, rather than doing everything all at once. It can minimize risks of waste landslides, methane gas explosions, greenhouse gas emissions, particularly methane, air and water pollution. It can even create income generation opportunities for people at and around the site. And semi-aerobic landfilling can be introduced by converting existing anaerobic landfills. So, if your city already has anaerobic landfills, you can still consider the rehabilitation of these by introducing the semi-aerobic landfilling method. What about the cons? Although its daily management is relatively simple, they still need the daily use of field workers and heavy machines. So the landfill management entity needs to make a clear commitment to secure the required funds, staff, materials and machines constantly for a very long time, usually for several decades of landfill operational period. Heavy machinery is especially critical for proper daily operation, but this is no different to anaerobic landfilling. Semi-aerobic landfilling can reduce environmental and health risks, but the method is limited when it comes to achieving a circular economy. Additional efforts to minimize waste inputs to the landfill, such as waste reduction, reuse, and recycling, must be made separately. This is easier said than done, but semi-aerobic landfilling is possible even when a 3R system is not yet established. And while semi-aerobic landfilling can contribute to greenhouse gas emission reduction, it has limitations when it comes to carbon neutrality. Let's take a quick look at where it has been implemented.
I am Monica Kingori, an Assistant Director, Environment, Kiambu County, and also the landfill manager. Here the site is called Kang'oki Dam Site, but wherever we are studying, we have the Kang'oki landfill site under Fukuoka technology. We have only one dam site where I'm studying, the Kang'oki Dam Site, which collects all the waste from all over Kiambu County. Waste comes even from more than 100 kilometers. The far end where we border Nyandarua, we border Nairobi, and then we border Murang'a. All the waste is coming here to one dam site, Kang'oki. For the last few days, we have been hosting 19 African countries for the African Clean Cities platform, and also through the SWAN, that is Solid Waste Management Network, has been here training the participants from different countries on Fukuoka technology and the waste management in Kiambu in general.
We are visiting Kiambu in particular because they are already implementing the Fukuoka method for landfill management, an idea that we are really challenging as a county government, and we can see it is working for Kiambu, so we believe and trust that it can also work for Homa Bay County.
This is a very good experience because when we say on-site exchange training, we all gathered here in our numbers, but we all have similar problem. But what is amazing with this on-site training, with the new technology called Fukuoka, landfill management technology, when you look at it, it is more manageable and more customized to any local products that you have in our own dump site.
For Zomba, it's an open dumping, and currently it's very full, and we have identified a new site, and our wish is to have a landfill facility. In this training, it has come at the right time when we are still at designing stage. So in my plan now is to talk to the council so that we develop this site as a landfill facility, incorporating the Fukuoka method.
Fukuoka method always focuses on stabilizing the waste from anaerobic to semi-anaerobic conditions. So the demo we have been having is using the local available, the most cheapest way. That is the 3-tier, which is 3 down and 4 up, plus a vent, all to allow enough oxygen to get down the waste for better decomposition.
I think the most critical thing that I take back home now is to actually construct a Fukuoka landfill method technique That will help stabilize our disposal site and ensure that we have a controlled waste system. But most importantly, to have gas emission pipes, leachate treatment, and reduce the amount of waste that goes to that particular cell so that we enhance the recycling. But even whatever we dump must be dumped in a proper way using the Fukuoka method.
The program is very important, this program especially, and I get so many experience in this training. So I return to my country. The first one is I will give a training for the staff and governments, local governments, and second, apply Fukuoka technology on the site.
So one of the immediate take-homes is that we are going to revise our solid waste management policy to be robust, and also, of course, focus on developing a solid waste management act and regulations, and also that they also have a network for waste pickers, and they have a lot of support in protecting the rights of the waste pickers. So it is important to have everyone on board in the spirit of sustainable development goals.
That's Module 3 complete. You can now be like a controlled semi-aerobic landfill and breathe. Don't forget to take the quiz and join us again for Module 4, when we'll look at the controlled landfill planning and common operations. We'll see you then.